Students, I'm telling you that the devices to measure current like ammeter and to voltmeter to measure the potential difference and even the ohm meter which measures the resistance, they are basically consisting of galvanometer inside, right? They are consisting of what? Galvanometer inside, right? So basically the device that is like the basic building block of the measurement of these electrical quantities is galvanometer, right? So galvanometer is used to make ammeter, galvanometer is used to make voltmeter as well as ohm meter, right, students? So that's what our today's main topic is. Okay, now what's the basic concept? The basic concept is the same that we studied yesterday. Like we have what? We should have a current carrying coil, and the moment acting on it, or the torque, or the couple acting on it, is given by this formula. Right, students? So this is the basic principle of the galvanometer. Torque on the current carrying coil placed in magnetic field. Right, students? Okay. So galvanometer is basically consisting of that. So what is it? A galvanometer is an electrical instrument used to detect passage of current. And using that current, since using that current, we are going to measure it. We are going to measure voltage and we are going to measure resistance as well because R is itself equals to V by I. We all know that, right, students? Okay. Its working depends upon the fact that when the conductor is placed in the magnetic field, it experiences a force. Yes, that's what I told you yesterday. As a current passes through it. So due to this force, a torque acts. I was telling you that this is the basic concept behind the construction of galvanometer, right, students? So here is the torque, the formula of the torque, right, students? N is what? N is the number of turns of the coil. Number of turns of the coil. And what is I? It is current. What is B? It is magnetic field strength or magnetic flux density, right? And what is A? It is the area of the coil. And what is alpha? I have already told you, it is the angle between B and A. Right, students? Okay, now let's go to the construction. The thing is, this construction thing is not going to be asked in exam. But students, you must know about it to understand the further upcoming things, right? Okay, so let me tell you what is this diagram consisting of. Since this thing is the core, a cylindrical core. Basically, this is the top view of the galvanometer construction. Right, students? And this is the core on which the coil is being wounded. So students, here is the coil, current carrying coil. Right, students? And definitely here is the magnet. Okay, so the current is entering from here. Here is the current, students, right? And when this current passes through this coil, a couple acts on it or a torque acts on it, and this coil moves, and we have a pointer connected to that coil. The pointer also moves, and the pointer is pointing on a scale, which is giving us the reading, right? Okay. So what is the deflecting couple, students? The formula of deflecting couple is this, DINA. Now you know, students, whenever we twist anything, it resists. Whenever we twist anything, it resists. Like let me stop sharing the screen and right instead I start switching on the video. Like if we talk about a wire, do I have it? Yes. So if I have this wire, right, and I twist it like this, and what's going to happen when I'm going to release it? It is coming back. Can you see? So when I twist it, when I release it, it is coming back. So whenever, since we twist or rotate any elastic thing, so what happens? Since it resists, it comes back due to the elastic potential energy stored, right? Okay, so this is what also going to be happening to the coil. Like there would be some restoring couple as well. What is restoring couple? It is the resisting couple due to elastic potential energy stored or strain energy stored, right? Okay, and what is its formula? Students, its formula is C theta. Like what is meant by C theta? Now you would be asking about it because you must have some background about it. Students, theta is the angle of deflection. Theta is what? Have I written it? No, I haven't. So let me write it. This is angle of deflection. What is meant by angle of deflection? Let me again switch on the video. Okay, students. So if I twist this wire less, it's going to resist less. And when I'm going to twist it more, like I more twist it, like I increase the angle, so it's going to resist more. So it's going to come back with more movement. Right, students? So that's the thing. The resisting couple must be directly proportional to the theta. Right, students? Okay. And C is the constant. What is C? C is the torsional constant. From torque, we call it what? Torsional constant. Right, students? Okay. Now the coil is going to be coming to rest when these two moments are going to be equal. So students, I'm going too slow in this topic because this topic has not been studied by the A-level students at all. So you have to understand it like very, very carefully, right? Okay. So the deflecting couple is equal to the restoring couple. So if we like equate them, then we're going to be like getting this formula. And if I make I the subject to the formula, I'm going to get this. And what about all these things? Like what things? C is a constant, N is constant, A is constant, B is also constant, right? Why C is constant? Because it is like torsional constant. B is the magnetic field strength. Magnet is formed, so it is constant. A is the area of the coil, it is constant. N is the number of turns of the coil, it is also constant. So it means the current is simply directly proportional to the deflection. So the thing is, as we increase the current, theta also increases, right? So that's the concept. Like increase the current here, which is entering the coil, and what theta is going to be increasing? This theta is going to be increasing, like from here to here. When the pointer is going to be moving from here to here, students, then this theta angle is going to be increasing. So it's going to give us the reading on the scale, right? Okay. So students, there are like different types of galvanometer. The older type of galvanometer is, students, this mirror rule method. Like when we didn't have the technology, we used this assembly to detect or measure the currents. Like students, you can see Like here is the permanent magnet, right? Here's the core on which the coil is being moved. Here is the moving coil, right, students? And the current is entering into it. And what is then further done? A lamp is used to throw some light on the mirror which is attached to the coil. So, students, when the coil turns, current enters coil. What is the second step? Coil turns. So mirror is mounted on the coil. So mirror also turns. Mirror also turns. Mirror turns. So this light, like let's say this is incident light wave on the mirror. And students, this is a reflected light wave on the mirror. Right, students? So what is going to be happening? Like this angle of the incidence of the light is going to be changing. So the position of the reflected light is going to be changing from, like, let's say this position to this position to this position on what? On the meter rule. Here is, students, the meter rule. Or a thing like scale. So these are what? 1, 2, and 3. These are what, students? These are reflected rays. Right, students? So depending upon that, this scale was calibrated. Scale is what? Calibrated. So this was the older technology to, make the galvanometer and hence the ammeter and hence the voltmeter. Right, students? Okay. So let's go further. The second method is, students, this pointer dial method. Like we must have a moving coil, and then let me tell you. This is like some more advanced diagram. All of the labelings are not needed for you people. Like if we talk about this is a terminal to which the current is going to enter. Here is a permanent magnet, okay. Soft iron cylinder, and forget about this. So now insulating support, forget about this. Lower control spring, cylinder support, forget about it. Pointer counterbalance, yes. This is important. Okay, pointer is attached to the coil. Where is the coil? Here is the coil. A zero adjuster is basically used to find, like, uh, apply the zero correction if there is some zero error in the ammeter or galvanometer. And students, there is some coil bearing को भी छोड़ दें, phosphor को भी छोड़ दें. Here is the scale. ठीक है, अब आप लोग सोच रहे होंगे कि सर इस पे मिली एमीटर लिखा हुआ है, गैल्वेनोमीटर तो नहीं लिखा हुआ. बेसिकली गैल्वेनोमीटर मिली एमीटर है. गैल्वेनोमीटर इज बेसिकली दैट एमीटर जो कि वो थोड़ा सा करंट मेजर करता है, मिली एम्पियर्स में या माइक्रो एम्पियर्स में करंट मेजर करता है. ठीक है, तो ये स्टूडेंट्स हमारी नीडल है या पॉइंटर है which is attached to the coil. ठीक है, आगे चलते हैं. अच्छा, अब इंपॉर्टेंट बात आ गई, सबसे इंपॉर्टेंट बात वो क्या है, लेट्स टॉक अबाउट इट.